Okay, let's go. I'm Mike Diggs, and this is me reading Wikipedia. What? All of it? Welcome back to Mike Reads Wikipedia. I'm 3 pages in. As far as I can tell, there are probably a few million entries. So we're not doing bad. Today's story is going to be about a random subject that I've discovered called the Clock of the Long Now. Let's see what we can find out about this. The Clock of the Long Now, also called the 10,000-year-old clock, or the 10,000-year clock, is a mechanical clock under construction that is designed to keep time for 10,000 years. It is being built by the Long Now Foundation. A 2-metre prototype is on display at the Science Museum in London. As of June 2018, 2 more prototypes are on display at the Long Now Museum and Store at Fort Mason Center in San Francisco. The project was conceived by Danny Hillis in 1986. The first prototype of the clock began working on December 31st, 1999, just in time to display the transition to the year 2000. At midnight on New Year's Eve, the date indicator changed from 01999 to 02000, and the chime struck twice. The manufacture and site construction of the first full-scale prototype clock is being funded by Jeff Bezos's Bezos Expeditions. Jeff Bezos there, the Amazon founder, who since just resigned as CEO of Amazon to concentrate on flying spaceships to Mars and the Moon. Bezos Expeditions, I'm sure, is an interesting thing to look at as well. With a $42 million fund, and it's being built on land which Bezos owns in Texas. Of course it is. In the words of Stuart Brand, a founding board member of the foundation, such a clock, if sufficiently impressive and well engineered, would embody deep time for people. It should be charismatic to visit, interesting to think about, and famous enough to become iconic in the public discourse. Ideally, it would do for thinking about time what the photographs of Earth from space have done for thinking about the environment. Such icons reframe the way people think. I want to build a clock that ticks once a year. The century hand advances once every 100 years, and the cuckoo comes out on a millennium. I want the cuckoo to come out every millennium for the next 10,000 years. If I hurry, I should finish the clock in time to see the cuckoo come out for the first time. That's a quote from Danny Hillis in the Millennium Clock, Wired Scenarios, 1995. The basic design principles and requirements of the clock are: 1. Longevity. The clock should be accurate even after 10,000 years and must not contain valuable parts such as jewels, expensive metals or special alloys that might be looted. 2. Maintainability. Future generations should be able to keep the clock working, if necessary with nothing more advanced than Bronze Age tools and materials. Optimistic view of the future there. 3. Transparency. The clock should be understandable without stopping or disassembling it. No functionality should be opaque. 4. Evolvability. It should be possible to improve the clock over time. 5. Scalability. To ensure that the final large clock will work properly, smaller prototypes must be built and tested. Whether the clock will actually receive continued care and maintenance for such a long time is debatable. Hillis chose the 10,000-year goal to be just within the limits of plausibility. There are technological artifacts such as fragments of pots and baskets from 10,000 years in the past, so there is some precedent for human artifacts surviving this long, although very few human artifacts have been continuously tended for more than a few centuries. Power considerations. Many options were considered for power sourcing the clock, but most were rejected due to their inability to meet the requirements. For example, nuclear power or solar power systems would violate the principles of transparency and longevity. In the end, Hillis decided to require regular human winding for a falling weight designed for updating the clock face, because the clock design already assumes regular human maintenance. However, the clock is designed to keep time even when not being wound. If there is no attention for long periods of time, the clock uses the energy captured by changes in the temperature between day and night on the mountain top above to power its timekeeping apparatus. Timing considerations. The timing mechanism for such a long-lasting clock needs to be reliable and robust as well as accurate. The options considered but rejected as sources of timing for the clock included self-contained clocks. Most of these methods are inaccurate. The clock will slowly lose the correct time, but are reliable. That is, the clock will not suddenly stop working. Other methods are accurate but opaque, meaning that the clock is difficult to read or understand. The gravity pendulum. Inaccurate over the long term, and it requires many ticks which create wear. If I just look at that, I can pull up, for those watching on video, a picture of a gravity pendulum, which is essentially a pendulum, like a clock as we know it. The torsion pendulum. Fewer ticks but less accurate. That brings up a picture of a mousetrap when you hover over it. So I'm not sure that we could power a clock with a mousetrap, but I imagine that there's potential energy in the spring and it slowly is released rather than rapidly released, and involves no cheese, because cheese lasting for 10,000 years seems optimistic, even with Jeff Bezos's money. The balance wheel, which is more accurate than a pendulum. Those of you that can't see the video, I'll describe the picture that comes up for a balance wheel, which is a large spring on a wheel, and I imagine the spring releases energy to the wheel slowly, so that it actually spins around, and that would wind up the spring again in order to release that energy again. I know nothing about springs and clocks, but I'm sure that that's roughly how it works. Water flow. I suppose this is like a water clock from the past. Yeah, and it brings up clepsydra as an ancient timepiece to demonstrate how water clocks used to work. They're apparently inaccurate and wet, which is reasonable as a description. The solid material flow. This brings up a picture of the pitch drop experiment, which is something we could look into, which, as I recall, is a jar of pitch, which I think is about 150 years old, and it's gradually been dripping into a second cup. There is a web camera, I think, where you can go and see that, and it drips about every 5 or 10 years, something like that. And I don't think anyone's ever actually seen it do it. Wear and corrosion, very inaccurate. No idea how you'd use wear and corrosion to actually work out the time. Rolling balls, very inaccurate. Diffusion, which is something clever to do with physics, probably. I've no idea. Tuning fork, again, I imagine that would have to be quite a large tuning fork to last for 10,000 years. Pressure chamber cycle, which is called inaccurate. An inertial governor. That's a governor or a speed limiter or controller. This device is used to measure and regulate the speed of a machine, such as an engine. There is a list here, and I don't think I need to go through all of them and try and explain them, because most of them don't mean anything to me at all. But essentially, they looked into an awful lot of variations on an existing clock, including the atomic clock, which I think is the one we use these days, and the piezoelectric crystal oscillator, which is what's in most people's watches. External events that the clock could track or be adjusted by. Many of these methods are accurate. Some external cycles are very uniform over huge stretches of time, but they're unreliable. The clock could stop working completely if it failed to track the external event properly. Others have separate difficulties. So again, there's a list here of things that we could possibly use externally to set the clock by or to make the clock work. So the daily temperature cycle, That's unreliable with global warming, I'd say, over 10,000 years. Seasonal temperature cycles, imprecise, and again, global warming surely is going to affect that. Tidal forces, they probably don't change much over 10,000 years, although I do know the moon is moving away from the Earth gradually. I'm not entirely sure what impact that has, but we could look that up. Earth's rotating inertial frame. No idea what that means. But in classical physics and special relativity, an inertial frame of reference is a frame of reference that is not undergoing acceleration in an inertial frame of reference. Who knows what that means? Stellar alignment, unreliable because of clouds. Solar alignment, unreliable because of clouds. Tectonic motion, difficult to predict and measure. Very difficult to predict tectonic motion because we can't predict earthquakes and volcanoes. So I don't think that would work until we find out more about that. Orbital dynamics, very difficult to scale. Vandalism. How on earth do they plan to use vandalism as an external event to make a clock work? Civil disorder, civil war, nuclear war, and an impact event. All very difficult to predict. So I'm guessing that what they were looking at was cycles of human activity there and warfare that we could predict, but we can't predict how many nuclear wars we're likely to have in the next 10,000 years, can we? Hill has concluded that no single source of timing could meet the requirements. As a compromise, the clock will use an accurate but unreliable timer to adjust an inaccurate but reliable timer, creating a phase-locked loop. In the current design, a slow mechanical oscillator based on a torsional pendulum keeps time inaccurately but reliably. At noon, the light from the sun, a timer that is accurate but due to weather unreliable, is concentrated on a segment of metal through a lens. The metal buckles and the buckling force resets the clock to noon. The combination can, in principle, provide both reliability and long-term accuracy. So let me just go back over that. What he's decided is that there are various reliable forms of timekeeping, but they may be inaccurate. So using a pendulum of some sort or a torsion spring would allow you to produce an accurate short-term time, assuming that you know what the time is when you start the clock, but it wouldn't provide an accurate measure of time over 10,000 years. So what he's done is combine the two into what he calls a phase-locked loop, where an inaccurate but reliable clock is reset every day by an accurate but unreliable clock because of the weather, which is the sun heating up a small piece of metal. That's fascinating, and probably the best solution I could think of, but then what do I know? Displaying the time and date. Many of the unusual units displayed on clocks, many of the usual units displayed on clocks, such as hours and calendar dates, may have very little meaning in 10,000 years. However, every human culture counts days, months in some form, and years, all of which are based on lunar and solar cycles. There are also longer natural cycles, such as the 25,765-year precession of the Earth's axis. On the other hand, the clock is a product of our time, and it seems appropriate to pay homage to our current arbitrary systems of time measurement. In the end, it seemed best to display both the natural cycles and some of the current cultural cycles that we use. The center of the clock will show a star field indicating both the sidereal day. Okay, let's find out what that is, because I could pretend I know, but I don't. Sidereal time is a timekeeping system that astronomers use to locate celestial objects. Using sidereal time, it is possible to easily point a telescope to the proper coordinates in the night sky. Briefly, sidereal time is a time scale that is based on the Earth's rate of rotation. It's a bad day when we don't learn something. And the precession of the zodiac. Around this will be a display showing the positions of the sun and the moon in the sky, as well as the phase and the angle of the moon. Outside this will be an ephemeral. There are so many. Why am I picking articles with words that I can't read? I'm sure you get that as well. When you read them in your head, they always make sense. When you read them out loud, they never do. In astronomy and celestial navigation, and ephemeris gives the trajectory of naturally occurring astronomical objects as well as artificial satellites in the sky, i.e., the position over time. The etymology is from Latin ephemeris, diary, and from the Greek ephemerius, exactly the same word, diary, journal, historically. That seems interesting that both the Greek and the Latin had exactly the same word. I imagine one came first. So outside of the moon phase ring will be an ethereal dial showing the year according to our current Gregorian calendar. This will be a 5-digit display indicating the current year in a format like 02000, that's the year 2000, instead of the more usual 2000, to avoid the Y10K problem. The Y10K will obviously be referring to the Y2K problem, which meant that all our computers, or many of our computers, might have reset in the year 2000 and stopped working. Planes were supposed to crash from the sky, and trains were supposed to stop running on time, and Brexit was predicted to happen 15 to 20 years later, and that actually did happen. Hillis and Brand plan, if they can, to add a mechanism whereby the power source generates only enough energy to keep track of time. If visitors want to see the time displayed, they would have to manually supply some energy themselves. Time calculations. Options considered for the part of the clock that converts time source, for example, a pendulum, to display units, for example, clock hands, include electronics, hydraulics, fluidics, we'll get these words right, and mechanics. You see, the word mechanics is more complicated as an English word than the word fluidics, really. It's just, I've never heard the word fluidics or fluidic logic. Now I have, I'll be able to include it in my ick words. Hydraulics, fluidics, mechanics. A problem with using a conventional gear train, which has been the standard mechanism for the past millennium to run clocks, is that gears necessarily require a ratio relationship between the timing source and the display. The required accuracy of the ratio increases with the amount of time to be measured. For instance, for a short period of time, the count of 29.5 days per lunar month may suffice, but over 10,000 years, the number is 29.53058882, which is a much more accurate choice. Achieving such precise ratios with gears is possible, but awkward. Similarly, gears degrade over time in accuracy and efficiency due to the deleterious effects of friction. Instead, the clock uses binary digital logic, implemented mechanically in a sequence of stacked binary adders, or, as their inventor, Hillis, calls them, serial bit adders. We won't bother looking that one up. In effect, the conversion logic is a simple digital computer. More specifically, a digital differential analyzer. Many words to look up here. A simple differential analyzer is something that most of us would sit there and go, okay, I'm sure that's important, but it looks like a very old machine. If I look on the link, the differential analyzer is a mechanical analog computer designed to solve differential equations by integration, using wheel and disc mechanisms to perform the integration. It was one of the first advanced computing devices. Looks like a Babbage type story, I'm sure. This binary logic can only keep track of elapsed time, like a stopwatch. To convert from elapsed to local solar time, that is the time of day, a cam subtracts from or adds to the cam slider, which the adders move. Another advantage of the digital computer over the gear train is that it is more evolvable. For instance, the ratio of day to years depends on Earth's rotation, which is slowing at a noticeable but not very predictable rate. This could be enough to, for example, throw the phase of the moon off by a few days over 10,000 years. The digital scheme allows that conversion ratio to be adjusted without stopping the clock if the length of the day changes in an unexpected way. That's going to relate, is my guess, to the sun, the use of the sun on a bendy piece of metal to reset the clock to lunchtime every single day. Location. The Long Now Foundation has purchased the top of Mount Washington near Ely, Nevada, which is surrounded by Great Basin National Park, for the permanent storage of the full-size clock once it's constructed. It will be housed in a series of rooms, the slowest mechanisms visible first, in the white limestone cliffs approximately 10,000 feet up the Snake Ridge. The site's dryness, remoteness, and lack of economic value should protect the clock from corrosion, vandalism, and development. Not those nuclear wars, those that they were predicting. Hillis chose this area of Nevada in part because it is home to a number of dwarf bristlecone pines, which the foundation notes were nearly 5,000 years old. The clock will be almost entirely underground and only accessed by foot traffic from the east once it's complete. Before building the public clock in Nevada, the foundation is building a full-scale clock of similar design in a mountain near Van Horn, Texas. The test drilling for the underground construction of the site was started in 2009. The site is on property owned by Amazon.com founder Jeff Bezos, who is also funding its construction. I imagine Jeff Bezos is developing a technology for him to live for 10,000 years and keep winding up his clock in his back garden in Van Horn, Texas, but we'll never know, will we? The lessons learned in the construction of this first full-scale 10,000-year-old clock will inform the final design of the clock in Nevada. The project is supported by the Long Now Foundation. Let's just have a quick look at them. They have a sign. The Long Now Foundation, established in 1996, is an American public non-profit organization based in San Francisco that seeks to start and promote a long-term cultural institution. Its aim is to provide a counterpoint to what it views as today's faster, cheaper mindset. Interesting that they're based in San Francisco, where Jeff Bezos and crew, Mark Zuckerberg, etc., and Steve Jobs, all created the faster, more instantaneous culture that we're currently living in. Anyway, the project is supported by the Long Now Foundation, which also supports a number of other very long-term projects, including the Rosetta Project to preserve the world's languages, and the Long Bet Project. We don't know what the Long Bet Project is, but we will find out one day. We're going to read the whole of Wikipedia, so at some point we are going to find out what the Long Bet Project is. Neil Stephenson's novel, Anathem, was partly inspired by his involvement with the project, to which he contributed 3 pages of sketches and notes. The Long Now Foundation sells a soundtrack for the novel, with profits going to the project. Musician Brian Eno gave the clock of the Long Now its name and coined the term Long Now in an essay. He has collaborated with Hillis on the writing of music for the chimes of a future prototype. Well, there we go. That's the Wikipedia entry for the clock of the Long Now. And I'm fairly certain that any of us that have lived through lockdown in what year is it? 2020, 2021. I've lost track. It's been a year now of that. And I imagine there's some resonance of the clock of the Long Now for anyone that's been locked in their house for over a year now. Thank you very much for listening. I will be looking for another random article tomorrow and trying to publish another one of these. Leave a comment underneath. Like, subscribe, send money, buy me coffees, be a patron. I don't know, all the things that you're supposed to say at the end of one of these videos, do those. Go and watch somebody else's video and then do all of the things that they ask you to do on my video or at the end of my podcast. Or do none of those. Thank you.